Hey, my tech friends, thanks for stopping by. Please like and subscribe if you haven't already. Let's continue to grow this channel. Hope you guys enjoy this video.
Hey guys, welcome to another homebrew video. Today we're going to look at Tiny 11 Beta 1, specifically what this particular operating system is, what it isn't, and whether or not you should use it on a mainstream system that has internet access. Stick around. Okay, so this operating system is built around the Windows 11 platform, specifically Windows 11 Pro 64-bit edition. Supposedly it's very shrunken down. And also, according to at least what I've read, it's not to be used on your public-facing computer. So in other words, it's designed for testing, it's designed for internal LAN use only. The developers made it very clear that this is not a secure operating system. It's not an operating system that should be exposed to the internet. But let's figure out why that is. Let's see specifically what's missing, what's active, what security measures are missing from the operating system, and how much is exposed to the outside when using it. So I'm going to continue on through the installation process like I do in most videos when we do these homebrew configurations. I'm going to try to only record the portions of the installation process that are different from your basic Windows 11 configuration. So if this seems trimmed down during the installation process, there's a reason why. Okay, so leading up to this part where you go through the installation process of Windows 11 is exactly the same as it is on full-blown Windows 11. So let's continue on the installation. So far we've rebooted, system's starting to come back up. I don't see any differences yet in the installation process between regular Windows 11 and where we are at this point. Okay, so we've finalized the installation process. Keep in mind, during the installation process, at no point was I prompted to enter a license key during the installation of this particular operating system. So let's continue on and see what this looks like and what this actually gives us. Okay, so we just loaded into our Tiny 11 Beta 1 application here. And specifically, we're looking at the Windows 11 desktop. You'll note that I don't have our network connection established. I try not to do that on any of these systems that I build that are homebrew machines until we run scans on them, making sure they're secure, making sure that there's security patches involved, and making sure we don't have any backdoor or weird things configured on these systems. So let's start jumping through some of these menus and take a look at specifically what we have. The first thing I want to do is I want to take a look at the actual system. According to the download, this was 23H2. I want to confirm that because I have a feeling it's not. And it is. So that's actually interesting. I didn't think it was because during the installation process, it looks much more like the 22H2 configuration of Windows 11. I believe in 23H2 that they made some slight changes to the installation process, and I didn't see them during the installation of this particular operating system. So that's something that I would say is different. On this particular VM, you can see we have 8 gigs of memory and we have 2 cores allocated to this particular system. It is a 64-bit system, so it's a 64-bit operating system installed as well. Let's continue on through the configuration process of this thing to just take a look at specifically what we got going on. I think the next place I want to go is the firewall, so we're going to go into the control panel. And I'm not a fan of these Windows 11 or Windows 10 menus, so we'll just go through the command logic so that way I don't have to click through 15 menus to get to one place. So if we look here, let's take a look at small icons. Windows Defender Firewall. Alright, we are turned on. Let's take a look specifically at what we have as far as our configuration. So before we continue on through the actual Firewall app to take a look at the app configuration, because this operating system, this Tiny 11 Beta, doesn't look any different than your full-blown Windows 11 operating system, what I intend to do here is I just want to change the background to something else, so that way it doesn't get confused between this and the other system, because we're going to do a comparison of the out-of-the-box configuration of the firewall between this Tiny 11 system and what we would get out of the box for a full-blown version of Windows 11 out of the box. I just want to make sure that we don't have any customizations inside the firewall controls that would allow remote access to the system. And the easiest way for me to do that without running the scan first would be to just check it versus the bone stock version of Windows 11 Pro. So let's just change something in here. Maybe we could just change the desktop background to a solid color. There we go. So now we have a solid color of black in the background. That's perfect. So now we know the system that's a Windows 11 system that has the solid color black in the background. That's going to be our Tiny 11 system. The system that has the full-blown Windows 11 look is going to be our full-blown version of Windows 11. Okay, guys, so I figure the first thing we could do here is, before we look at the firewall configuration on our slimmed down version, let's take a look at it on basically a fairly stock Windows 11 desktop. I say fairly because we have some things installed on this Windows 11 machine for the sake of testing, to put a little weight on our Windows 11 machine. This is not an actively used system, so it's really just for the sake of what this video is it's just to show you a rough idea of what the core features and functions are through the firewall. So we'll see that we have the AllJoyN router set for private access. The app installer goes through both the private and public. Now keep in mind, these are the profiles that you're going to usually have on a Windows 11, 10, really any Windows system going back to like the XP days is going to have a network profile configuration on it, and out of the box it's going to be private and public. Once you're on the domain, you'll get the additional option for domain private public. Generally speaking, most people are going to use the private configuration on home networks, and then the public configuration on your your Starbucks locations, your public Wi-Fi. And basically what that is the public connection is just a firewall tries to secure more than on your private connection, so you have more access through your private than you do through your public. Okay, so let's just take a look through here, and you'll notice that I specifically highlighted Clip Champ, and the reason why is because it just doesn't look like a great feature or function that you should have through your firewall, but it is built into Windows 11. It's part of the latest update, which I believe is some kind of software to modify videos or edit videos. I don't really know too much about it, but at any rate, you're going to see your private and your public. We'll go through here, take a look at what we have. We have Cortana by default that goes through. Email and accounts, the feedback hub, get help, Google Chrome. Obviously Google Chrome isn't going to be a default, but we have Chrome installed. The majority of people watching this probably have Chrome installed on their home machine, so I would just say that should be a given at this point. We have Microsoft Edge. We have start menu, which again, I'm not really sure specifically on the start menu why it is that we need that going through the firewall. And that's something I'm actually going to dig into throughout the course of this video to figure out specifically why the start menu needs access to the firewall. But that doesn't sound like a great idea to give public access to your start menu on your Windows system. But, I don't want to digress too much here. So the store experience host. So Wi-Fi Direct is for your WFD printers. I'm not a fan of WFD printers, so on my machine, typically I'd probably disconnect this. And the reason why is because ultimately I just use TCP/IP for my connections. If you need the WFD access in order to get to a printer, then generally speaking, that's probably not a very secure, because the Print Nightmare patch kind of helped that, but not 100%. So, again, use at your own risk. The Windows calculator, I don't know why the calculator needs access through the firewall. That's kind of scary to me that the calculator of all things in the Windows system needs access to the firewall. So at any rate, this is basically what your configuration is going to look like out of the box on your Windows 11 machine. Obviously Zoom is installed on this machine, so if you don't have Zoom installed, you're not going to see that. But everything else for the most part is going to be what it is inside of your Windows 11 system. So now let's jump back over to our Tiny Beta 1 system and take a look at that firewall configuration. We'll do a slight comparison between the two and take a look, see what's different. Okay guys, so this is the Tiny 11 machine. And if we do a quick comparison, we could see that AllJoyN router isn't set to go through public, but it is set to go through private. Everything else in here, for the most part, looks about the same. I don't see any real differences as far as additional things being added to this thing. There's that start menu thing again. There's the WFD. I really don't see anything different from the sake of being added. Now, I do see quite a bit of difference of things being removed. So this is a much shorter list than what you're going to get on your Windows 11 Pro machine. But still, there are things in here. So next, I think the next part of this check is let's take a look at the installation, the add remove programs, to see if there's anything else installed on this machine. Okay, so since we already have the control panel open, I'm just going to dip back through the control panel to get back to just the base control panel. And then once we're in here, I'm just going to go to Programs. I'm going to go to Uninstall a Program, and I'm going to specifically look and see what we have installed on this machine. So we have remote desktop connection installed for some reason, which doesn't make any sense because Microsoft Terminal Services is built into the actual console itself. So generally speaking, if you want to just open up remote desktop access outbound, you just type in mstsc inside of your run command and you hit enter and it'll bring you up to your remote desktop connection. So that makes me concerned as to what that actually is. And I'm curious, since we couldn't see it inside of our firewall configuration as an inbound configuration, I'm wondering if we have something weird in here. Let's take a look. Let's open up a command prompt on the system. And let's take a look at the netstat connections, the listening ports, to see if we have port 3389 listening. And if we don't have 3389, we'll take a look real quick at the PID to see if we could see the process identifier for terminal services and do a comparison for the PID based off of the listening ports to see if we do have a listening port for terminal services on a custom port. All right, so we don't have anything listening specifically on 3389. Let's see if we have anything listening. So we do have quite a bit of things listening, but I don't believe this is anything outside of the norm from your typical Windows 11 system. Keep in mind, Windows 11 is noisy. It has a lot of listening ports and configurations on their actual stack for Windows 11. Windows 10 is far less noisy. Windows 7 is far less noisy than that, but Windows XP was just as noisy. Windows XP made as much noise as Windows 11 does as far as the listening port configuration. But let's take a look at these port configurations and see specifically what's listening here. And in order to do that easily in Windows, these are going to be your inbound ports, the stuff on this side here. And we're listening here. So we're listening on these particular ports on this side. Now on this side here, these are the product identifiers, or the PID numbers. So what we're going to do here is we're going to open up Task Manager, and we're going to do a comparison of these PID numbers to what our listening ports are. Okay, so let's take a look at that. What we're going to do here is we're going to open up Task Manager. So that's just simply right-click on an open space inside your taskbar, Task Manager. And then what you're going to do is you're going to go here to these three lines with the dots, which is the details option inside of Windows 11. And here's the product identifier. So this is the PID number. And this PID number is going to match what we have here as far as a PID number. So if we want to know specifically what 5040 is on this machine, we would have to look for 4248. If we come into here and we look specifically for 4248, we're going to see that it's listed as a service host. Now the thing is with the service host, how are we going to know what that actually is? Okay, so what we're going to do in order to get that process identifier, since it's listed here under the service host, is we're just simply going to right-click on our currently open command prompt and open another command prompt. And then we're going to run a command, which is specifically task list space / SVC. And then we're going to do a pipe space find space / I, which is in. And then we're going to quote out that specific PID number and hit enter. And what that'll do is that'll bring back specifically what's hidden under the service host through the command logic to figure out what that actual listening port is listening for. Okay, so let's get that started. Okay, so what that actual name is the CDP service. So specifically what the CDP service does in Windows 10. So in Windows 10, it was introduced in, I think it was 1607 as a full-time service. Prior to that, it was on the Windows platform in Windows 10, but it was disabled. And what it does is it gives the telemetry and the remote access for your application. So for instance, if you have like an Android phone and you want to send messages through your Windows system, that's what that service does. If you have an iPhone and you want to send messages through your system, that's what that service does. That service also integrates your configuration for your augmented reality. So basically, if you have the augmented reality AR headsets, or the 3D headsets that you could buy for gaming, that particular service is what integrates connects that control into Windows. Why it exists on this system is beyond me, since we're missing parts of the OS that be required for this actually to work. So in reality, that service should probably be shut off from a security standpoint. So another thing we're going to look at real quick is what I'm going to call these 49664 ports. And the reason why I'm interested in what these are is if you realize that these things are going in series, right? So we got 64, 65, 66, 67, 68, 69, and we have a variety of different PIDs listing on these different ports, which is typically bizarre. However, there is something that was introduced in Windows called dynamic port allocation, which came out really in about the tail end of Windows 7. Windows 8, 8.1 all had it. Windows 10 got a little better about it. Windows 11 has it in spades. And basically what we have is in a dynamic port allocation, Windows can take a wildcard and listen on a specific wildcard port for specific applications, which allows it to be different ports at different times. Generally speaking, these ports are used for broadcast and not necessarily receiving data, but let's take a look anyway and see if there's anything funky with these port configurations in here. So I think what we're going to do is we're going to focus on this particular one here, the 1720. And the reason why is because generally speaking, 4 is always system, 736, 560, those are generally low PIDs. So the lower the PID is, the product identifier, generally that means that it starts with Windows. So the lower the number is, the more likely it is that it's tied to an actual Windows application, a built-in application. The higher the number is, that's usually stuff that's started up later after the operating system loads. So that's something important to keep in mind and to focus on when you're looking at things like this, because if the number is low, then generally it's built in. So it's something that's going to start up first. So if you have number 4, you know that's system, and say number 5 was something else, then you know that those two things are tied to the system itself. Because Windows needs to load before it can load applications. So even with like ransomware and spyware and malware, those generally get a higher PID number because they have to load after the operating system is already up. So if we look, we have 1720 here, which is again another service host, which we have 1720 here. And if we go back to our command prompt here, and we just hit the up arrow and we change this to 1720, we have a specific task here under the service host for schedule. Okay, so schedule is pretty self-explanatory in Windows. That's part of the task scheduler. What we need to do, though, is we need to figure out what is running through the task scheduler for that particular PID that it would be listening on a port. So let's take a look at the task scheduler on this machine and see what we have, if anything, that's been modified in the task scheduler to start up with the Windows operating system. Okay, so what we're looking for is what's running under this particular port in our task scheduler. So what I did is I opened up the task scheduler already in the background, so you don't have to hear me click through and type a variety of menus. And here's what we got starting and running on Windows. So each one of these locations should give us details specifically as to if there's anything customized in here to start up or run. Right now I don't see anything in there. It's also possible I'm waiting for this thing to load. Okay, so it looks like we have an Xbox task, although it doesn't say that it has run yet. Well, the history is disabled, so it's not going to show us when it was last run anyway. So what's interesting is we have the Cloud Experience host running for whatever reason. I don't know if it's actually working or not, or if there's something funky in here, but the fact that it says that it's running, it's not typically a good sign. So what that Cloud Experience host does is it creates your object or your task inside of your Azure AD integration services. So basically it would give the ability for the system to phone home to connect to your Azure configuration to set up user accounts, remote access, things of that nature. The fact that it's running on this system is kind of bizarre. Let's see if that exists out of the box on Windows 11 by checking the other system real quick. All right, so we're in the other Windows 11 machine now taking a look at this, and if you'll notice that this does not start automatically with Windows 11 in the actual legit Windows 11 side. So that tells me straight away that that system has something additional added to it for Azure access or Active Directory Entra ID access built into the actual operating system or configured on the operating system to phone home, whereas this does not. So that's something to keep in mind, because if it has that function or that feature built into it, embedded into the operating system, that would give the ability for whoever created it access into the actual system. Okay guys, so now that we're back in this system here inside of our Tiny 11 system, let's give the system a static IP address. And let's throw it on the Nessus scanner real quick and see what we come back with. And we could compare that to what we have on the bog stock, the Windows 11 Pro machine. Now keep in mind that the latest patch revision on Windows 11 Pro, at least from, I think it was this past Tuesday, added a older piece of code back to the system to create a security flaw in the system. So we may or may not see that on the system depending on when the system was actually built. But let's take a look anyway and see what we got. Okay guys, so welcome back. Now we're in the Nessus scanner. So I've done both. I've run the malware scan and the pen test scan on the Tiny 11 machine, the Beta 1 system. Now, generally speaking, I wouldn't go as in-depth as I did in this video in a lot of the other videos. And the reason why I went in-depth is because this is a beta system, and generally beta systems are buggy or have questionable things in them. And also, the author, whoever built this thing, was very, very transparent in providing information and saying that this particular system is in beta and is not designed to be used as your primary OS. It is designed specifically to use as testing, and that's it. So you shouldn't be using this for anything outside of testing itself. However, I was curious how far it is in the beta, how unsecured it is, what bugs and issues does it have, as well as what limitations it has. So we took a look at the malware scan, and in the malware scan, I literally only see 7 things. The 7 things that are in the malware scan are just informations based off of configuration. There is no viruses, malware, or issues with ransomware or anything else in the system. The system itself is clean. So the other thing we took a look at was the full pen test, and honestly it looks about the same as our full Windows 11 system. To just give a quick comparison, this is Windows 11 no firewall, just the full-on base configuration of Windows 11 Pro with nothing else added to it, 23H2. You could see we have exactly the same number, so 1 medium and 40. And if we drill into them, this is that configuration issue or the error that Microsoft, for whatever reason, released back into the Windows 11, which is I'm guessing a development bug where they decided to use an older piece of code to update and then re-released a fault or variable into the operating system that existed prior. Because if you run 22H2 through the same scanner, this 1 medium doesn't exist. So it's something specific to 23H2 that Microsoft re-released into the wild. That seems about on par for Microsoft. So if we dip back to the configuration here for the Tiny 11, you'll see that we have the 1 and the 40, which is exactly the same as what we had before. So it looks, from a security standpoint, pretty well secure. But keep in mind, there are certain configurations that are not going to show in this system as an issue. Like, for instance, when you configure a Windows 11 machine to connect and communicate with Azure services, this system's not going to see that as a flaw or an issue, because it just assumes that you're trying to communicate with your Azure, your Entra ID configuration on your cloud. So when you see an info of 40 infos in one vulnerability, but we know that it's trying to communicate or phone home, that's not going to be seen as a flaw through these actual scan protocols. So that's why it's important that you really have to dig into the operating systems a little bit on top of just running the scans to make sure that your configuration on those systems are legit. You know what I mean? So I mean, generally, a base vanilla system that is released by the provider, the vendor, is not going to have those configuration standards built into it. But those aren't considered vulnerabilities. Those are, configurations that you would have in a system to configure it to communicate with a cloud infrastructure. So from where I sit, or what I can tell, I would say that, we look pretty good from a security standpoint. Now, I did find when I went through the plugin configuration here on the actual system, we can see now our ports. So our 135 port, which is our RPC service. We could see our 445, which is the SMB 2, 3, or 1 configuration, depending on what's enabled on that machine. I did look. It looks like it's just SMB 2 and 3, so we have SMB 1 turned off. Then we have down here, this is our 64, and then our 65, and our 66. Our series of ports. And if we look at these specific things, we could see this is the RPC service again, and we have the RPC service again, and then we have the RPC service again, and so on and so forth. The problem is the description on these particular things are considered unknown RPC services. So some of these are actual legit, right? So we got Windows event log. That's a known. But right here, where we have an unknown RPC service or an RPC service, is not generally good because the Nessus scanner updates on a daily basis. It should know specifically what these UUIDs, these actual identifiers are for the object is. So right off the bat, even though the system doesn't tell us that these are alerts or malware issues, the truth is that they could be any of those things because the system just doesn't know what they are. So what we got to do now is we got to jump back over to that Windows 11 machine. We got to dig a little further into the port configurations to check to see if we could figure out specifically what's running on that. And we'll look at some more configuration on that actual Tiny 11 machine. Okay, so let's jump back over into our Windows 11 Tiny Edition. And let's take a look at a couple configurations. And then we'll end out this video. And we'll have to continue on this Tiny 11 system to dig further into it. But as of now, big shout out to the guy who developed this thing, especially for being transparent on that it's beta and not to use it as your primary OS because, it's not a primary OS yet. But it is a fantastic build so far and should be something that we get excited for in the future for a tiny version of an operating system. Okay, guys, so we're back over on our Tiny 11 system. And if we take a look at this, these are specifically the high port configurations that we were seeing, the 64, 5, 6, 7, 8, 9, and then the 73. And so this is just, these are known services. So just these guys up here, I wouldn't worry about. That's known, that's existed in all versions of Windows. Event log and task scheduler, also relatively known processes. Now, why task scheduler and event log are listening on specific ports for remote access? That's a good question. The printer configuration for your spooler service, for whatever reason, is running on a high port instead of the generic TCP port for the printer configuration, but that might be due to that WSD configuration. Things that shouldn't be on here is the remote access service console. I don't know why remote access service console is listening. So this isn't like RAS. I'm talking about remote access to the services Microsoft Service Console. So services.msc. This is the remote access service that's listening for that remote access to services. No idea why. And then we have an Entra policy agent. Again, that's the phone home portion to connect to an Entra ID system for your directory or Active Directory configuration from Azure. That's set up to listen right now. So based on these two alone, I don't think I would use this system if it has any access whatsoever to the internet. And that's just my take on what we see here inside of our security configuration for this beta operating system. Now, I do want to go on a limb here and say that while I don't think it's at the point where I would use this on the internet. It is looking good. So we do have a lot of bonuses to this operating system. So the first thing, I just want to circle back real quick and go into the configuration on this thing and just clarify that we don't have terminal services listening. I don't see any indications of terminal services, term, remote, anything like that listening for any kind of remote access to this actual system. So we don't have, and specifically not based off of port number, but based off of the actual, the product itself, the executable. Also, keep in mind, throughout the video, I flip-flop between PID as process ID and product ID. It's process identifier. It's just I'm specifically looking at certain products that are connecting and speech. Anyway, so what we have here is we don't have anything specifically listening for terminal services. We don't have anything for remote desktop services. Keep in mind that terminal services is a product that was end-of-lifed in 2003 R2, and RDS, or remote desktop services, is a product that was invented in 2008. It's the same product, but they decided for whatever reason to change the name and reinvent it. So you may see remnants of terminal services on operating systems or new things called RDS, or remote desktop services. It's the same product. So anyway, we don't have anything remote access turned on this machine through any kind of configuration like that. However, we do have remote access as far as like the remote access standard configuration for Microsoft. The remote assist rather. And we also have Entra ID. We have Azure integration services turned on. So generally speaking, if somebody did want to access this, like if the developer needed access into the specific system, they would have access into the system. That said, I don't think it's done vindictively. I think it's just part of the beta program. Right now, he's still in the process of building the thing. And he, like I said, 100% transparency said this is not a system that you should be using as your primary OS. Now, in addition to all of the configuration, the network configuration, the remote access, things of that nature, there is something that is, I guess, the elephant in the room about this particular operating system. And that elephant, of course, is size. So this tiny operating system is actually tiny. It's legit small. The configuration you're going to find on your Windows 11 machine, generally speaking, with all the updates on 23H2, as of today, which is March 27th, you're looking at about 25.9 or 26 gigs of storage on an operating system to run the OS. And that's on the full-fledged version of Windows 11. Whereas on this particular system, we're only using 8.5 gigs. So the operating system is substantially smaller than the operating system on Windows 11 Pro or the full build. With that said, I don't know that I see any speed differences. The thing is you got to understand that the OS itself, even if it's not bloated, the OS code, what's required to run just the core operating system of Windows 11, really anything that was like Vista forward, is just slow to begin with. There's just so much dormant code and crap still in the operating system. It just makes it slow. From a service structure or a functionality structure, I'm sure that you would probably run into issues running things on this particular system that may not work correctly because you're missing portions of the operating system. But from a system that you're going to use just to browse the internet, once it's no longer in beta and the developer has cleaned up his Azure configuration and connection stuff, then this is something that we should definitely circle back and take another look at because it is definitely a lot smaller. It does run relatively well. At least from the security scans, I don't see anything as far as vindictive stuff in it. We just look like we have either leftover configuration in it because it is in beta, or we have stuff that's in it that the developer needs in order to access the systems remotely to keep them updated for the time being until the beta program is over. But at any rate, I don't think I would use this as a primary OS yet. But if you want to use it as testing or something to screw around with just to check it out, I'll put the link in the description. Definitely check it out. And again, thanks for sticking around. Also, if you have a way to get in touch with the developer and tell him that I think he's got a solid, good platform to build off of, definitely let him know, drop him my comment, or put a comment down below and let me know where to find him, and I'll give him a good thumbs up. All right, guys, thanks a lot.
Take it easy.